I'm going to talk about even versus odd functions. Now, the official way to find out is to take your original function and plug in negative x. And if you get your original back out, then it is even. Or take your original function and plug in negative x. And if you get the negative of the whole thing, then you found an odd function. And if neither one of these is true, otherwise it is neither. Now, let's do it with a simple one. Let's do it with a. So for a, f of x is the 2x to the fourth minus 6x squared plus 5x minus 15. So if I plug in negative x, this is for problem A, then what I get is 2 times negative x raised to the fourth. Goodness, why can't I get, there we go, raised to the fourth, minus 6 times negative x squared plus 5 times negative x minus 15. Well, when you square, when you take any negative to an even power, you have an even number of negatives and they all cancel. So this becomes 2x to the fourth minus 6x squared. But 5 times negative x becomes minus 5x. And then we still have minus 15. Now, if you look at the original, this term is the same. Minus 6x squared, this is the same. But this one changed sign. That one is positive and this one is negative. And so this does not equal. So f of negative x does not equal f of x. So this is not even, but it doesn't mean it's odd. If it was odd, then it would equal negative f of x, but negative f of x would be negative 2x raised to the fourth plus 6x squared minus 5x plus 15. And it certainly doesn't equal this. So what we find out is that it is not, oh, I was trying to get bold. Here we go. We find out that it is not odd either. So that leaves us to conclude that it is neither. Is neither. Now, there's a lot faster way to do that. If you will look at the coefficients, let's erase this stuff I wrote here. If you look at the coefficients of each term, we have 2, negative 6, 5, and negative 15. Each of those is attached to an x with a certain power. This is the power 4. This is the power 2. Even though it's not written, this is the power 1. And they never write this. But if you needed a constant times x to a power, it would be x to the 0, because x to the 0 equals 1. So if you look at the powers, not the coefficients that are attached to each of the x terms, but if you look at the exponents of each x term, notice that some of these are even and some are odd. Some exponents even, some are odd. That means that this is neither, without plugging anything in. If you look here at B, 7 is odd, 5 is odd, 3 is odd, and it's not written here, but it's 1. It's odd. That means that B, without doing any math, is odd, because with polynomials, the exponents tell the whole story. So let's look at C. It has only even exponents. Remember, a constant is an even exponent because it's x to the 0. This has only even exponents, which means that C is an even function without doing any plugging of, without plugging in negative x. So I'm trying to write that here. There we go. Now, can you tell me what is D? Well, I see a 3 and a 2 already. I can tell you it's neither. What is E? I see a 3 and a 2 for exponents, so this is neither. For F, I see a 5, a 3, and a 1. This is odd. Those are all odd exponents. For G, I see 6, 4, 2, and basically 0. So this is even because those are all even exponents. And for H, I see an exponent of 5, of 3, and of 1, which makes it odd. And that's the quick way to do this.